Good evening everyone, Paul Daniels here again with what I fix daily, and today is a bit of an interesting one. This is a Acer 5552 and it's actually one of mine, but I'm just trying to get it ready to on-sell it because I've got more than enough machines floating around here. And the problem is when I was testing it, one of the USB ports doesn't work, which is a bit of a bummer. So which one was it? It was this one over here. Now I checked the other USB ports and they're all good with power, so I can make the assumption well, that was a useless little thing to take off. My 5-volt always is good, so I'll probably have some sort of short or a blow or something. I guess we'll find out. Get the main board out. Fair number of screws on these ones. Now I was going to use the webcam on this one along with the main camera that I'm using here. Unfortunately, the little laptop that I'm using at the moment just doesn't have the grunt to be able to encode the high definition video concurrently. It's fine recording the audio, which is what you're listening to right now, but yeah, I'll throw the video encoding in and it has an absolute fit, and that's with Open Broadcaster and using ultra fast and things like that. So I just need to get my IBM E550 up and running, all set up, and I'll be able to use that live cam again. I mean, it's not surprising that the little laptop can't handle it. It's only some lightweight CPU. How many more dozen screws do I have to remove? Have we done this one? Let's have a look. This one's staring at me right in the face here. I've handled a lot of these 555 2Gs, and so far as Acer laptops go, they're not too bad. I used one for quite a while as my everyday machine. Alright, let's flip you over. I'm going to need my metal spudger, I think. Oh, for fuck's sake. God damn, don't tell me I've got to replace that. You better not have broken off. Fear you have. No? Oh, good. Whew. Believe me, I'll not be in the mood for that sort of crap today. Ah, no. It's the last thing I think I'm going to take this from the middle. Obviously, if I had broken that, I'd just have to get a new keyboard. So in trouble with these damn, I don't know what they call them, like chocolate or chiclet or something sort of keyboard, and my god, I hate them. That's it, I need my metal spudger. Alright, let's try that again. Don't you lose that. Yeah, so sorry I don't have the webcam running in parallel with this. Would have been nice. Next time. Come on, out you come, keyboard. Go. Now, unfortunately for this particular fault, I am going to need to access both sides of the board, so it's I'm gonna have to completely come out. At least testing it shouldn't be too much of trouble, since it's the 5 volt line issue. We just put something like a little 5 volt powered USB light or something like that in there. Easy enough. Come to think of it, it's been a year or two since I've worked on one of these. Sorry, microphone was in the wrong spot there. Funnily enough, when I was looking for the schematics and board view for this, I decided I'll go check bad caps and just do a search there. And the first hit that came up was actually my own. Unfortunately, I did have the schematic. What are you stuck in there for? You can't be stuck. There we go. Okay. Gotta love the use of masking tape in these things. I mean, really. Masking tape? Okie doke. Well, we've got our 5 volt there. Let's see, what was on the top side? Where the hell's the... what? Am I looking at the wrong side? Oh, right. It's, okie dokie. And I forgot my multimeter and everything else. Be right back. Okay, we're back. First thing I'll do is check for shorts. No point putting power through when I don't have to. I was also going to have my multimeter come through on the screen, but nah, another great idea sent to the depths. Alright, so what do we want? This is the chip here. We want a 678. There are output voltages. So let's have a look. 0.6, okay, no short there. 1 and 2 of the always. No short there, that's 0.6 again. I'll just set this up. You see that? Might be just enough for the video. Okay, so we're in diode mode, and let's see the first 3 pins here. So we've got 0.6, which is fine. Pin 1 and 2 on that side, 0.6, fine again. Pin 4 is sys on. Oops, damn it. Hello. What are we doing for short there? That can't be a short, surely. Alright, that's kind of weird. I would have thought with pin 4, I would not expect that to be a short to ground. I'll have to have a look at that. The reason why I don't think it should be a short to ground is because sys on is shared between both the ports. So if it is shorted, it should have taken out the other ones. So the fact that always on is shorted, sorry, not always on. The fact that our sys on shows a short to ground is a little bit of a concern to me. And naturally, I can't power this damn thing up. Yeah, brilliant. Let's see if we can see 5 volts on always on. So plug you in. It should be on. And naturally my cables are always tangled, because that's the way it's meant to be. And let's see, pins 2 and 3, which are the middle two here. I've got 5 volts there. Alright, let's have a look at pin 4. I'm showing 0 volts, which means it should be active. Now let's have a look at pins 8. Yeah, so we've got nothing there. So theoretically that would imply up front that this chip is blown, theoretically. The reason why I say that, actually let's test it another way. Okay, this is my testing tool. Lights on, so there, lights on. No light. So we know those are working. And pin 4 says that we're at ground, so it should be letting power through. Now the real pain here is that I don't know if I've got any spares. Not really the sort of thing that you have lying around. Well, for the sake of alright, let's go back to diode mode and double check everything. I mean, we've got 0.76, that's hardly a short. So it would appear something's gone kaput in there. So I'll get rid of that chip and go try find a replacement. 60. Let's find ourselves a pair of tweezers that can do the job. You guys are a bit small. There's a bunch of parts around it. Those tweezers are not going to cut it. Pull. Focus on what you're doing. How about these ones? And these ones have got remnants of iPhone 6S on them. Oh, crap. There we go. That's what's nice about PC boards. Generally, they're marked, so we can see where pin 1 is. Okay, so now we've got to go find another one of these. Alright, I'm back after a rather protracted process. We ended up, we're going to try and replace this USB power switch, the one that's U24. The only trouble was, according to the readings I was getting over on the other ports, it was active while it was high, so we were getting output while the signal line was reading 5 volts. And when I switch it on, it changes over to about 2.5 volts, which is still a bit of a strange value, but again, I'm not sure what's going on there. To make things more complicated, it seemed like that was an active high, as we said, but then when I checked the part number, it was I think it was a 3510B, And when I look at the B suffix, it turns out that that's actually an active low chip. So I don't know, I've been going all over the place. Anyway, I don't have any of those, obviously. And the closest I could find was from a Toshiba P750, and that's what I've got here. This is a I think it's a G752 something. I'll bring it up later. So I'm about to hot air this on, and fingers crossed it actually works and doesn't blow the crap out of everything. It is pin compatible at the very least, so yeah, hopefully it legitimately is compatible. Get some freshly squeezed Rossmann flux. Make sure I've got everything disconnected. Yeah, there's no power there. Yeah, this does illustrate very well why it's nice to have donor boards, and why, generally speaking, working on PC stuff sucks balls. Because even if you have the same model laptop, so many times it's not the it can be a different variant, all sorts of things. Thank God for leaded solder, eh? I don't think that's on properly. Nope. Needs to be pushed back a little bit. The reason why I can't tell is because I am just free eyeballing this, and my eyeballs are getting a little old. Not to say I'm blind, but there's a lot of details I do miss lately. Oop, too far. Dance, you little fucker. For the purpose of our testing, that will suffice. Alright, here goes. We have our special test contraption. You watch, this thing isn't going to work. Yeah, nothing. But like I said, if I plug it into the others. Come on, there you go, light. So I don't know what the hell's going on there. But I will plug in the keyboard and see if I can get it to fire up and see what happens there. Hopefully I didn't just blow up the USB control. That would be most unfortunate. Still no power, no power. What the flippity flip. I gotta admit, the socket feels sloppy, but it still doesn't make any sense. Okay, well, I'm gonna pull this off while it's on. Come on, you. Now it's still running, and I'm gonna check our voltages. Okay. So we have pin 4 reads. Oh, yeah, idiot. Pin 4 reads 2.67. Pins 2 and 3 read 5. The output side reads Sweet FA, meaning stuff all. Okay, so that's. I'm missing something obvious here. 5 volts, 0 volts, 0 volts. I really am missing something obvious here. I have kept the other chip, just in case. I should take this board out and have a look on the other side. Maybe it's something profoundly, stupidly obvious. Let us begin the long, annoying process of getting these off. Pardon me. See, now, if we had a donor board, a proper matching one, we wouldn't have to care about all these oddities. We'd just go, well, let's swap that part and see what happens. And if that doesn't work, well, let's move on to the next part and see what happens. But because of this, we have to fiddle and fart around. Okay, what have I got? Power cable. How are you connected, Mr. Power Cable? Very awkwardly. It's going to be easier. Should be able to get it turned over without having to... Yep, there we go. Okay, so it's this port here. Now if I look into the port, I mean it's loose, but yeah, sometimes ports just feel... I'll check the continuity of the various pins. I mean there's a bit of... Yeah, actually there's a bit of... No, sorry, I thought there was a bit of weirdness in there, but it's just the way the light was filtering through there. And I am stuck to the board. Okay, let's check the continuity. Okay. So that pin there. Yep, we're good. Yep, that pin there. Yep. So the pins seem fine. Let's check diode mode on the power pins. Yeah, we're showing 7.2 volts. I wonder if it's a no, maybe. Just thinking, wonder if it's a diode protection circuitry. That still doesn't make a lot of sense because I should see 5 volts unless it's shorting it out. Pin 5. So what we have here is we should get... Okay, that's a Zener. Or is it Shrockety? Oh, good God, Paul. 5 and 2. Okay, let's have a look. Diode mode 2.5 and 2.6, which is pretty normal, but I think that's forward conduction. 22, 7.2. No, that seems normal. So basically it means if the voltage on USB VCCA exceeds 7.2, it will break down and short it to ground. So yeah, that's normal. Behaving as it should. I am really confused why I'm not getting any voltage. Come on, there you go. Freedom. Just going to check this board under the limited amount of... nothing looks bad that I can see. Then again, there's only my limited vision at the moment. Let's clean this up, this whole area. Actually, that might be an idea. I should try a heat test. see what comes up. See if anything comes up. Oh great, I'll put alcohol all over my circuit board. This is why, instead of making videos right now, I genuinely should be preparing my workbench with screens, keyboard, computer, everything, so I don't have to keep printing out these goddamn things, because I'm really getting aggro about it. This might end up being a freaking dud night. Oh well. What are you? Can't believe it. One port. That's all. That's wrong. Come on, come on, come on. Get in. Don't force it. That's one connector you really don't want to force. Where'd my tester go? No, there we go. I swear I saw that blink just then. I am not kidding you. I swear I saw that blink. Maybe it was just reflection off here. Alright, obviously nothing's cooking up there. No surprises. We didn't get a short in the first place, so yeah. Ah. I'm going to point this to the camera, and maybe while I'm doing this it might show up in case I don't see it. Nope, nothing there. Oh, I think I just saw some sort of heating up, but really it just feels like normal evaporation. Yeah, normal, very low level warmth. Yeah, I think that's all it was. Okay. Yeah, bastard. Why? Nothing. Just gonna check the diode mode on those. Hello. 318. Six 1 2. Six 1 3. We call that 6 1 2. God's sake, Fry. Oh, that's interesting. They're both 318. And naturally I do not have this for the other ports printed out. Fuck. They may not even be the same, and they're on the other side of the board here. Oh well. Alright, that's it. I'm gonna have to order in some replacements of these and see what happens. I'm very sorry we couldn't fix it. That's the way it goes sometimes, and like I said, particularly particularly common for PC laptop repairs, unless you've got an exact model copy. Yeah, you spend a lot of time wasting time. It's 2 in the morning. I haven't been able to sleep thinking about this particular little hiccup, and I went back over things again, and that 2.7 volt sys-on was really narking me a lot. It just wasn't right. It should either be 0, 3.3, 5, something like that. But that 2.7, it was in the middle of nowhere. So I went over the schematic and I had a look. This is it here, Q30. And it just didn't make sense. If I was showing direct no resistance on this ground pin here, and that resistor there was 100k as it should be, but when I got sys-on, which was 3.3, it should have pulled sys-on hash down to ground. I should have been getting 0 volts there. Instead I was getting 2.7. So I thought, well, maybe one of these chips, the power switch chips, was holding it up, pulling it up, or something through a bleed. So the easiest thing to do was just remove that Q30. Now, as soon as I did that, sys-on hash got pulled up to 5 volts, stayed up there obviously. Fortunately for this particular transistor, the 2N7002, I have a lot of them, so I replaced it. That's it right there, and bang, straight away my lines were as they should be. I was getting a full pull down to 0, which activated my USB port that I've been fighting with the original 3210, I think it was 3210. Anyway, with the original power switch chip, it was working. But what I noticed then was that this power switch chip, which does the ports that were working before, started really getting hot and cooking up a real good storm. So I thought, oh, okay, maybe that's what's been happening. And it should have twigged, because I was getting the output on this port even when really I shouldn't have been. So a case of those little messages in the back of your head just not pushing through to the front. Typical. Anyway, so that's really cooking up a storm. So even with the USB flex taken out, so it's got a problem, I would say. I'm going to take this off the board, and I will use that spare one that we got from the other board, and I'll put that there instead. So it's an interesting case. By the looks of it, we've chased the wrong part, so to speak. Oh well, yeah, live and learn. But the sad thing is, you probably don't really learn, because the next time something comes up, it'll be different. Make sure the power's disconnected. So here we are, 2 o'clock in the morning, and I'm going to put some leaded solder on this one, because it's right next to that FPC connector, and I really don't want to have to change that. There we go, bit of leaded. Oh god, why didn't I put my fume extractor on? Alright. See if we can pull this sucker out without melting my FPC. Oh, wait for the solder to melt first, Paul. Dumbass. Come on. God help me if that FPC melts. Yeah, got a little upset. Hopefully not too bad. Guess we'll find out. Just won't stay down. Bugger. Alright, I can actually put this one down using just soldering. There's my goot wick. Is good goot. Yeah, you'll have to excuse me. Being 2 o'clock in the morning, I am going to be doing this under the microscope, magnifying glass. Okay, let's get some rapid cooling going on. I will point out this cooks up pretty quick. So as soon as I apply power, we'll see. Well, it's not cooking up. Alright. Next step. This is plugging into what was the faulty. And let's turn on the machine. I said turn on the machine. There we go. That's good. So that was with what was the faulty port. Now I'm going to plug the dual USB ports back in. Hopefully I didn't butcher that FPC. Yeah, it has tightened up a little bit, so I'm not happy about that, but it is still serviceable. Okay. Now, try. This is now plugged into what used to work. Now notice how this time when I plugged it in, they don't light up, whereas before they would be lighting up. I should have known that was my sign. Didn't pay any attention to it. There we go. It's working. So we're fixed. Fantastic. Oh my. Alright, I wanted to do one confirmation test, and that is to boot from that USB port. That was weird. Oh great, my keyboard doesn't work. There we go, it's just batteries running out. Oops. Oh, look at that. Eulogy for Peppy the Frog. Thank you very much, Lewis. Alright, we are done. I think I'm going to say that probably the last time tonight. It's 2:30 in the morning. I am very pleased that this is finished. I can actually sell this now with confidence without having to try and barter my way through some sort of lower price or something like that, just to deal with one broken port. Bit of confusion there. Board views backwards because of the way the file format was done. A bit of a red herring, where it was this port here was the one that was working correctly. It was this one over here that was faulty, but because we got a nice bright light and because the data was still running through when I would boot from it, it misdirected me, whereas this one over here was doing the right thing. So there you have it. What can I say about this? PC laptops are a pain in the ass to fix. How about that? I was lucky. I was able to find a substitute high side switch, and it's not cooking my finger, thank goodness. And I was additionally lucky I had plenty of spares of those logic trans MOSFETs. So all good in the end of the day. Thank you very much for watching. I'll see you guys next time. I'm going to go try to get some sleep. Thank you.